in logic, just like in algebra, we have variables. Now, typically in algebra, we use X, Y, and Z, although we have used other letters, but typically we use X, Y, and Z in algebra. Now, in logic, we have what's called propositional variables, and these are variables that represent our propositions. The typical letters that we use for propositions are P, Q, R, and S. And the truth value of a proposition is denoted by a capital T or a capital F for true or false. In this video, we're going to concentrate on what's known as the negation of a proposition. So, let P be a proposition. So this is going to be our propositional variable, P. The negation of P is denoted as this little symbol in front of the P and means it is not the case that we have P. Another way you can say it is not P. If I had a proposition, Michael's PC runs Linux. That's a proposition because it is a fact. It could be true or false. If we let P be the propositional variable for this, then I could write the negation of this as a couple different ways. I could write it as it is not the case that Michael's PC runs Linux. Although usually you don't hear people running around saying, it is not the case that I went to get gas, or it is not the case that I made turkey for dinner. You don't usually hear people use that language. So another way you could say it in a more relaxed setting, Michael's PC does not run Linux. If I wanted to say, using our proposition variable, Michael's PC runs Linux, that would be just P. The negation of that, to say that Michael's PC does not run Linux, would look like this. Okay, another example, using negation, we can say, my smartphone has at least 32 gigabytes of memory. Okay, so let's say I want to state the negation of this in English. Well, if my smartphone has at least 32 gigabytes of memory, that means 32 or more. So if I want to negate that and say the opposite of that, I want to say my smartphone has less than 32 gigabytes. And another way to think of that, if we think back of our inequality symbols, if I say up here for our original statement, my smartphone has at least 32 gigabytes of memory. If I wanted to write that using inequality notation, I would say is greater than or equal to 32. Which means if I look at that on a number line, I would have 32. I would have greater than or equal to, which means I would include 32. If I want to look at the negation of that, which means it is not the case that this is true, it's the opposite. So I would want to do the exact opposite of this. So I would have this. I would not want to include 32, and I would want it to be less than. So when I write this in English, I'm going to say my smartphone has less than 32 gigabytes of memory. It is not going to include 32 in this case. So if my variable for my smartphone has at least 32 gigabytes of memory, if my propositional variable for that is Q, then the negation would be not Q. This is the way we would say it in English, using the negation in English, and this would be our symbol. Now, this is a good time to introduce truth tables. And a truth table is a mathematical table that uses logic to show the truth values of a compound proposition depending on the input values. So we're going to start with a nice, easy truth table. We want to show the truth table for not P. Since the only variable in this expression is P, we're going to have a column for P. Then we have a column for our expression. Now, P could be either true or P could be false. If P is true, then not P is going to be false. If P is false, then not P is going to be true. So this is our truth table for the expression not P. This is what's called the negation operator. And the negation operator constructs a new proposition from a single existing proposition, so that would be our P. This will now lead us into learning about other operators.